Now we are ready to implement the quicksort function. So let's do that on the very top. So the public interface is a void quicksort given array and then given size. We can call it. Then remember that we need to first to shuffle given array and given size. Then we are going to implement the recursive version of the quicksort. Let's call it quicksort, but that's not public use. It's just used internally by quicksort. Given array and then starting index and then last index size -1. Then quick quicksort recursive version is given data as an array and then start index low, last index high is there. Base case, if high is the same as or smaller than low, then return. That's just the base case, one element only. And then let's find the pivot by calling partitions given array and starting index and then last index. Let's do partition. Then k is index of the pivot. Then left hand side of the pivot from low to k minus 1 do quicksort recursively. That's a smaller size problem, so we assume solution is available. And then right hand side of the pivot data k plus 1 up to high. So that's the right hand side. Then sorting is done. Now in quicksort we call qsort before the definition is given, so we need to give a prototype void qsort array high low. So that's the prototype of a qsort. And then also partition is used before its implementation, so we need to give prototype int partition array low and high. So the prototype of partition is given. I guess now we are ready to call quicksort and then test it out. So let's go to the main function and let's do test q quicksort there, and then let's give a prototype test quicksort, and the quicksort quick underscore sorter. So let's make it the same name just for clarity. It's there. And then let's implement a test quicksort function. Let's copy the data we tried with a partition and then call quicksort data with 11 array with a size of 12 size. So 0 to 11 is size is 12. And the quicksort is defined in some other file, so we need to give a reference as a prototype void quicksort array and the size. That's the reference. Then everything looks okay. Terminal, compile. We have an error. Quicksort CPP line 10. Shuffle is not defined. The quicksort line 10 shuffle is no, yeah, the implementation is later, but it's used here, so we need to give a prototype shuffle array and the size. Prototype is provided. Then surrender. So quicksort CPP 49, surrender time. So those are in C time library. We need to, we have added that, and then CSTDL library is included because of srand and the rand C time, but null pointer is not. Okay, error message is regarding null pointer. Null pointer is in IO stream library, so we need to add that. Now let's compile again. All good. Main function. Let's quicksort the tester. Let's set break after initializing the array. Start. So data is unsorted the one. Now complete the quicksorter. They are sorted out. So we have briefly tested the quicksorter algorithm.